So let us now try to address the question which you have asked regarding designing a Turing machine for a given language. Okay. So the question is like this: you have to construct a Turing machine to accept the language L as W such that W is equal to A to the power n, B to the power 2n. Okay. So in the regular class, I have already solved one example where L is of the form A to the power n, so W is of the form B to the power n. We have already designed a Turing machine where for the words of the language of the form A to the power n, B to the power n. So here it is not, it is just an extension of that problem. So what will be my algorithm to design this Turing machine? So first, so suppose I have a string of A, B, 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 B. Okay. So what I will do? So I will take first the leftmost A. Okay. Take the leftmost A, mark it as X, move towards right. Take the leftmost B. Okay. So mark two B's at Y. Okay. And then move back to left. Then I will mark this as X and move towards right and mark two B's as why? Because this is 2 times b. So the occurrence of b is 2 times the occurrences of a. So I'll mark two b's as y and then move towards left. And finally, if I do not find any a, then I have mapped all a's with x. Then move towards right and to check whether I have any b or not. If any b is there, I will reject. Otherwise, if I find a blank symbol, I will accept that. Okay, so let us now try to design this thing. So suppose I am in Q0. Okay, so this is my starting state Q0. So so what will happen? So with A, okay, it will mark it as X and move towards right. Okay, and go to state Q1. So Q1 is the state where I have already marked as a given A as X and searching for the corresponding Y's. Okay, so in Q1 I may hit another A where I have to go towards right to take the leftmost B's. So if I have A, then I will just move towards right. Okay, or it may so happen that I may hit a Y also. Understood? So if I hit a Y, then also I will just skip that Y and move towards right to get the leftmost B. Okay, so for the leftmost B, what will happen? So for the first B, I'll mark it as Y and move towards right. Okay, Y comma R. Okay, and my state is Q2. So this Q2 represents the state where I have marked a single Y for a given X and I have to mark another Y. Okay, so if I have another Y, if I have another B, I have to again mark it as Y and move towards left. So because why I have to move towards left, because now I have to search for the leftmost A now. Okay, so I'll go to Q3. So in Q3 I will again start searching for the leftmost A by moving the tape head towards left. Okay, so in Q3 if I hit A, I will just skip that A and move towards left. So how will I decide that this is my leftmost A? Okay, so for the given A I have marked as X. Okay, A is suppose, and I have suppose for a given A I have marked it as Y. So two Y's are there. and I have B B B B suppose. Okay, now now after this y has been marked, I move the tape head towards the left. So for any a, I'll go to the next a, so till I find a x. So x denotes the boundary where I have the leftmost a to its right. Okay, so I may hit another y also. So for y also, you just skip that y and move towards left. Okay, now find a if you find a x, this means you have reached the boundary. Okay, then you don't do anything and move towards right. Okay, okay, now that if that will be a, then it will iteratively, it will recursively, the automata will move in this fashion to process the things. Okay, now if all the a's are consumed, what will happen? So if all the a's are consumed, then I'll have automata like this, where x x x y y y y y y. Okay, okay, so what I need to check now? So if all the a's are consumed and replaced by x, I need to check whether on the right hand side I have any b left or not. Okay, so what I need to do, so I need to move forward. So let me write it this way. So for a given y, then I need to move towards right. Okay, and suppose this is q4, and in q4 for any occurrence of y, I need to move, I need to, I do not have to do anything and move towards right. Okay, and if I found a blank symbol, that means I am done. If I found a blank symbol, then don't do anything, move towards left and go to q5 as the final step. But any y if you find, the Turing machine will halt. Okay, so now let us now try to formally define the Turing machine. So my Turing machine is M. What will be my set of states Q now? So Q is equal to, so M is the Turing machine, which is a tuple of Q. Then I have a tape alphabet, I have a sigma, I have transition functions, then I have starting state Q0, I have blank symbols B, and I have set of final state F. Now let us try to define these things. So my Q will be Q0, Q1, Q2, Q3, Q4, and Q5. Okay, what will be my alphabet set? Sigma is just A and B. Okay, what is my tape alphabet set? Is it will be A, B, X, Y, and capital B blank symbol. Okay, what is my Q0 is Q0. Okay, so in this way you can define the transition functions also. The final state is Q5. Okay.